Standard 7.2 says that a student can use the information from one representation to create another, and that includes factoring, because we're going to take the expressions and rewrite them in their factored form. We're going to create a different representation of the same expression. Now, when we factored, recall that we used prime factorization. Now, since 2 is a prime number, 2x to the 8th is 2. We don't have to worry about the 1. 1 is not prime, so it's just 2 times x 8 times. 1, 2, 3, 4, 5, 6, 7, 8. The number 12, remember we divide by 2 to start, right? 2 times 6 and 2 times 3. 6 is equal to 2 times 3. My prime numbers being 2 times 2 times 3. So 12x to the 4th is equal to 2 times 2 times 3 times x 4 times 1, 2, 3, 4. There we go. And if we went back and calculated 2 times 2 times 3, 2 times 2 is 4, 4 times 3 is 12, so we did that correctly. Again, remember your list of prime numbers 2, 3, 5, 7, 11, 13, 17, and so on. Always start with 2. That way you won't forget anything, you won't leave anything behind. 18 is 2 times 9. 9 is not divisible by 2, but it's divisible by 3, so 3 times 3. So 18x to the 3rd is equal to 2 times 3 times 3 times x 3 times. Then what they have in common is their greatest common factor. So each of them has a 2, but there are no other numbers that they have in common. And then they have an x in common, another x in common, and finally a third x in common. But because I'm out of x's in that bottom term in 18x to the 3rd, I don't have anything else in common. So my greatest common factor is 2x to the 3rd. Again, they all have 2 times x to the 3rd, 2x to the 3rd, 2x to the 3rd. So when I factor 2x to the 8th minus 12x to the 4th plus 18x to the 3rd, that greatest common factor comes on the outside. I'm actually going to rewrite this down at the bottom so that we have room. So that's going to be equal to 2x to the 3rd times whatever's left over in each of the terms. Please watch your signs. 2x to the 8th was positive, and so that therefore I'm left with a positive x to the 5th. There's 5 x's left over. That's x to the 5th. There are no numbers. There's no coefficient left over. In the negative 12x to the 4th, so it's going to be a negative, I'm left with 2 times 3 and an x, which is 6x. And then that 18x to the 3rd was positive. I'm left with 3 times 3, no variables. 3 times 3 is 9. So there's my factored form of 2x to the 8th minus 12x to the 4th plus 18x to the 3rd. We are equal to 2x to the 3rd times x to the 5th minus 6x plus 9. And what I just showed you there is if you were to distribute that back in, you would end up right where you started. Let's do the same thing here for number 12. We'll take that negative into account when we're before we're through, but we'll look at that at the end. So we're going to start with 15b to the 4th. 15 is not divisible by 2, but it is divisible by 3. 3 times 5 are both prime, so we're done. 15b to the 4th is equal to 3 times 5 times b 4 times. And then 3b to the 7th, 3 is a prime number, so I don't need to think about factoring that because we want prime values. 7b's. There's 3, 4, 5, 6, 7. So what do these guys have in common? Well, they have a 3, and then a b, another b, a third, and finally a 4th b. When it comes to variables, you're always going to have in common the smallest exponent that you have for whatever variable it is that you're looking at. So because 4 is the smallest exponent on the variable b, that's what they have in common. The same thing actually happened over here. 3 was the smallest exponent that the variable x had, and x to the 3rd was part of our greatest common factor. That'll always be the case. So my GCF is equal to 3b to the 4th. 3 and 4 b's, 3 and 4 b's. And let's recall that that goes on the outside. Now, anytime the leading coefficient, the leading term is negative, you want your GCF to also be negative. You want to make that negative be the coefficient. You want it on the outside of the parentheses. So if I redistribute that back in, I need this term to be positive so that this term will be negative when I multiply it back in. Okay, so what this guy had left over then is just a 5. Just the number 5. There are no variables left over. All those b's were taken out, were taken into consideration when we took out the greatest common factor. And notice that negative 3 times positive 5 is the negative 15 that we need. And then the 3b to the 7th is positive, so I need a negative times a negative to make that term positive. And left over from that term is b to the 3rd. No numbers, just b to the 3rd. And again, negative times negative is positive, which is what we wanted. So the representation, the what did we call it in the standard? The different representation is negative 3b to the 4th times the quantity 5 minus b to the 3rd.